Hello, everyone. Welcome to the DMM working group. I'm Sri Gundavalli, Cisco.
Satoru Matsushima from SoftBank.
Okay. Uh, First thing, please be aware of the IETF's intellectual property rights. When starting a presentation, you must say if there's IPR associated with your draft. Please read through these IETF specifications pointed here, RFC 3978, 4748, and other related documents. And next is the note well. This meeting is hosted under certain rules and regulations. Please be aware of these participating rules. If by participating in IETF, you agree to the following IETF processes and policies. Please be aware of these, read through them, and if you disagree, you have to leave the meeting. We need a note taker. Any volunteers? Okay, thank you. Okay, we have volunteer and JavaScript. Any? Okay. Okay, a quick update on the working group documents, right? If you, these are the documents in our working group. One is the mobility aware transport network slicing for 5G. It's almost in near completion. Satoru-san is going to give his review, the readiness state, readiness comments on the document. The other three documents are in different phases: architecture discussion on SRv6 for mobile user plane architecture for DMM, SRH reduction for SRv6. These are somewhat, at least two of these documents are relatively new. The authors are going to give an update on where we are. I think with that, anything on the agenda, Bashing? Anything, anything you want to add or delete? Any comments? Okay. If not, we go to the mobility aware transport network slicing for 5G. Satoru-san is going to provide some comments. Yeah.
So we have an agenda later on. The TN mobility aware transport network slicing draft will be present from John. But before that, I want to leave the note a little bit. So summarize the discussion in the mail. So after working draft code discussion, we have whether the intended status be standard or informational, and boundary between other related work. So regarding the intended status, standard or info, so DMM working group agreed that this draft should be informational. But one of the Ops AD will discuss on that. It should be standard since it has a young module. So I don't know the exact reason exists, but I think it could be one of the discussion point down the road. And the next thing, the boundary between other related work. The content of the draft really concise, but describing the related work is the consume the almost part of the document. The draft follow a slicing model defining AC as a service by TIS working group, and slice mapping model for 3GPP entity are defined in a 3GPP spec. So this draft explains how both AC as a service and 3GPP slice mapping works, and define a small young module for AC as a service. That's the content of the this draft. So, and additional discussion point remained here, I think, is security. So currently, the draft mentioned about the the security consideration mainly on Yang and network configuration operation model. But I think a little bit um, mention to the risk or security consideration by reducing UDP source port number range. That's one thing. The last bullet mentioned the working group last call. Due to the latest working group last call made with the intended status with standard, but I believe that the working group consent to bring this document as an information. So I'd like to ask working group whether we need another working group last call or not. Okay.
Yeah, thank you, Satoru-san. Any questions, comments? John, anything you as an author?
Thank you, Sri and Satur-san. It matches what we have discussed, so I'm familiar with most of what has been written. The only new part that I see there, apart from the discussion on the mailing list, is the security section. And I did have a discussion with the TEAS people on the way they did their ACAS Yang models. And the only thing I found that was important for us is the variable that we have, which is the UDP source port range, which is why I have it there, but we can have a discussion on whether anything, in some cases it may be sensitive. So this is the only data that this node is, this draft is considering. So that's what we have there.
Yeah, typically in the security section, you cover the residual threats, right? I think, when we went through that security section, we did not see a substantial, text covering all the aspects. So some thought, otherwise we can send it, but ISG will very certainly will send it back as a discuss point. So
yeah. We can have a discussion offline on how we did that, and I can bring it up on the
right. Any other questions, comments? Okay.
Just, yeah, thank you. Lionel Moran, Huawei. I was wondering if, could you please elaborate why the Ops 80 thinks that it should be a standard rather than info?
Actually, I'm not much aware of the reason why one of the AD say that if the Yang model be included, it should be standard track. But I don't know. But if that AD discuss to push this draft to be standard, only reason with the Yang model be included, I think I have to ask the author to leave the Yang model from the draft.
I'm asking in the ESG Slack channel whether that's a general requirement for Yang modules, because that's kind of new to me. But I think in this case, you're actually augmenting another Yang module. And that Yang, if that's true, and that Yang module was defined in a standards track document, if you're going to augment that, then they might try to make an argument that you're augmenting a standards track module, so it also should be standards track. But I'm not sure that even that necessarily actually makes sense. Right. So,
okay. Sorry, John, go ahead.
So I don't understand this fully, but what I understand, let me say from the discussion with the AD. So there were two aspects. There was a draft in TEAS that explained most of these structures, including a layer 2 bearer. What they did not have was a layer 3 bearer, and that was a question of timing. That's why otherwise we would probably have implemented this layer 3 UDP bearer part in that same, and we would just refer to that. but that draft had progressed to a standard, it had passed that stage where they could add anything. So that's why we have this structure here. And the question that comes up is now, if we want to extend this to include other UDP considerations like Geneve or something else, some other UDP, then what would we continue to extend this or start something else? It's something on that order that is the issue. But beyond that, I cannot comment.
Yeah, I can take an action item to try to chase down ops ADs and see what they think about this.
Okay.
So I don't think that should necessarily impede us from
Right.
making other sorts of progress, except for there is considered to be a difference between a working group last call for an informational document and one for a standard track document.
Exactly, because this draft was adopted with the assumption that it's going to be informational spec. Suddenly, for us to change the status to standard track, it's the bar has to be higher. So,
And if you want, we can also request an early security directorate review, if you think that would help. You'd like that? Yeah. So you guys can do that. You can just check the button on the data tracker and request a sector review. And if you want me to do that, I can do that too.
okay, thank you so much. Which is the next question?
Do you have some talk on
No. Eric, you want to give an update on you wanted a few minutes, right? Sure. Thank you. Good chair.
I just want to make a general announcement that now is the time in our annual cycle where the NOMCOM has released the list of positions to be filled. I don't intend to run for a fourth INT-AD term. Even if I did, there's no guarantee they would select me again. So if you want to be an INT-AD or the area director of another area, or you want to fulfill one of the IAB roles or anything there, you should definitely apply. You can nominate yourself. If you don't want to nominate yourself, I can nominate you. If you're interested in being an area director and want to find out more about what's involved, there's an Ask Me Anything, an AMA on Thursday. I can't go to that one, but you can chase me down and I can answer any questions you may have or try to, or you can chase down any other area director and ask them any questions. So please review the list of open positions, see if it's something you want to apply for, and by all means, put yourself forward. Thank you.
Thank you, Eric. Next, who is the first presenter?
Really?
Who is the first presenter?
I think
We go with Ajay.
John.
John, we go with this track. Okay.
For the
John, you want to give an update on the open issues?
Should I request? So requesting. Okay, I think we've probably covered most of the changes that were made, but I'll just go through them quickly so that the working group is aware of each of the steps that we took since the last meeting. Most of these were discussed on the mailing list, but here are some of the details. From release 17 to 18, the major change that was made was to address a comment that the relationship between the SNSSAI and the EP transport, which were in section 3, and that of the Yang model, which was described in section 5, was not clear. So the what we did was we split that section 3.2, the former section 3.2, into two sections, 3.2 and 3.3, because it was just too long. And 3.3 is addressing the comment about how the SNSSAI and EP transport, which are defined in 3GPP, relate to the Yang model that's in this section 5 and the rest of the ACAS. So that was the change that was made. Related to that was also a question about section 3 procedures and 28.5.541 and how 3GPP defines things, so there's a question about, we like to do the implementations here while 3GPP defines interfaces. So this question had come up in other working groups, and one of the authors, Lewis, had suggested that what we could do is what was done in other groups like TEAS on similar issues, and that was to put a note there or put some text to the effect that it's not the purpose of this document to standardize or constrain the implementation of slicing. So the implementation could do, or could be anything that 3GPP, within the confines of 3GPP. So this draft is not trying to alter that. Rather, this was trying to show an example of how this could be done. So it was more an illustration than a specification there. So that's clarified over there. Sorry. Then I think the last one was a question about the Yang module itself, whether it was maintained by IANA, and the answer was no. And the reason is that there are two types, I guess. There's an IANA maintained module and an IETF module. And if IANA does not maintain the module, then it should be marked as not N over there. So those were pretty much the changes or the questions that were addressed. At the moment, I think now I thought that we'd keep it as informational, but now that's something that we need to look at. So whatever the working group decides is fine on that. The other comments related to section 3 are addressed, and the Yang model is not maintained. But now the question of the security, um, I haven't got that in the slides because we were not prepared for it. But what I did was to take the security section from similar drafts and TEAS and look at what was changing. So they also did this similar as what I have there, except that the data that they're referring to are different data, not UDP port. So to that extent, I think the security has been covered, but I don't know if anything else is missed. I couldn't think of anything, but I think it's a good idea to get a security review ahead of time.
The concern about the UDP source port be reduced is the kind of the reducing the entropy
Right.
for certain level of the security level.
We do mention that in the draft, but the question of the security implications of that is something that a deployment must consider, is all that we have so far. But I think that's all I have. Happy to take any comments.
Thank you, John. Any questions, comments?
And by the way, thank you for the working group for all the detailed reviews. Appreciate everything.
So I think on the security, I think Eric said we can issue a request to the security directorate to get some feedback. John, we'll do that. And I think that hopefully it will give you some really, yeah.
Thank you very much.
And the other question is whether do we need another working group protocol or not?
Any comments from the group on this?
We went through the working group protocol once, but it went well. But whether we need to just got some fact went through the last call with the right correct intended status.
Someone replied to me on Slack that they were under the impression that if it has a Yang module in it, it should be standards track. So, which I find a little surprising, but I haven't confirmed that with other ADs yet, but one of the ADs did tell me that that was their understanding. So I find that a little odd, but if I get other information, especially information to the contrary, I will let you know. I did have a question that I haven't been tracking this document closely enough, but in the attachment circuit as a service, where we're requesting specifically a GPU tunnel, why do we request specific source ports? Isn't that a matter for the provider network to make their own choice?
Yes, but what we're doing is we're using data structures that are defined in 3GPP 28541. And one option would be to ask 3GPP to allow specifically the use of a UDP port. But another option and the one we pursued was that 3GPP already has a a parameter that says ACAAS module. So now we are defining what that ACAS module in here would do with the UDP. So we don't have somebody that wants to implement this doesn't have to go to 3GPP specifically to have this.
I guess I'm still a little confused because we're requesting an attachment circuit, meaning
Right.
we're attaching to some network. Isn't it? I mean, if we were to say like, please give me a slice, doesn't that suffice? Why do we get to request other specific parameters about how the slice is actually implemented?
Yeah, so the reason for that is it's in the draft, and I can try to give you a summary. The summary is that you could have a network that is detached. I mean, the transport network that implements this is separated by a network that cannot express this slice intent. And that's carried by the UDP port to that provider edge.
Gotcha. So you need to arrange for the
Right.
arrival coordinates
Right.
at the other end. Yeah. Okay. Thank you.
So, John, one question: what does it take to separate the Yang model from the what are the efforts required from your point of view, if need be, if the conclusion is if you decide to go that way, as Sun was hinting, right?
To separate the Yang model from
From the main document.
That would probably another little RFC there. I don't know. But I can,
Yeah, that would be possible option. So just define the very small model,
Yeah.
but I don't know whether the right venue for that draft.
if that's the approach that we need to take, then that's okay.
Can you discuss with these guys to host that
Mhm.
Yang model in their document?
They've already gone to past last call, and that is why we couldn't include it there. So that was the whole, I mean, this was, even at release 16, they had passed the stage where they could include it, which is why we took this option.
Then it has to be a separate standalone.
It has to be a standalone document.
But yeah, maybe one page.
Okay, sure.
Yeah, okay, that might be. That way we keep this information into the Yang model standards because they have that weird requirement.
Yeah.
Right, we meet the, yeah.
We could do that.
Okay.
Okay, the shepherd will make the decision and we go from there. Thank you so
Thank
much.
you.
Next is in order.
US.
Just a quick clarification. So the decision is to get rid of the young model and keep other things and make the information.
No decision yet. That's one of the consideration is, yeah,
Most likely option.
most likely option. Most likely option. Thank you. Which the next one?
US.
US on. Sharing the slides. is on, right?
Yes, yeah.
Hello everyone. So I'd like to make update about this draft about SRv6 end.m.gtp6c behavior. Next page, please. So please let me recap this draft. And so in the SRv6 more user plane, so we are now utilizing end.m.gtp6e behavior, but this behavior utilizes two seeds in the SRH. SR header, and but this is very difficult to process in the hardware in the high speed. So this draft is proposing to make this behavior as familiar with hardwares. Next page, please. So after the last meeting in Bangkok, so working group adoption has been completed. Thank you for chairs and all members who reviewed this draft and give a feedback. And the current state, please go to the next slide. So after the working group adoption, so now we are discussing about the, some topics and about the design among the authors. So there are the two options to achieve this behavior. So we are now talking about the order of the bit field. So in the current draft, we are proposing the upper one. So this format is following the current end.gtp.6e specification. So we just utilize a free bit as a remainder bits, but following the end.m.gtp4e, so there are we can put the argmob session field at the last of the IPv6 seed. So this is also reasonable because the information to restore the IPv6 destination address is concentrated on the head of the in front of the seed. So it is a reason, but so we are now discussing carefully. So which one is better for the hardwares? Next slide, please. So the next step is RFC, but this status is informational. So now we are discussing. So once the discussions are closed, so we can do call the adoption of the RFC.
Oh, you mean last call?
Last call, yes. We'll make the update in the next IETF meeting.
So the key open issues at this point is just one.
Yeah,
nothing,
yes.
No other.
Yes.
Okay, we need some reviewers. I think before we talk about last call, we want some reviewers and discussions. Can someone sign up to review this document, please? Any volunteers?
So the comment from the hardware perspective is welcome.
Okay, thank you.
Thank you.
Thank you so much. Any other reviewers? Anyone else? Okay, maybe we'll, I know it requires a service expertise. We'll ask in the working group.
Yes.
Okay. Yeah, please. You may have to repeat the question. Yeah.
Yes, the things you are talking about SR header, those type of things, and then you are involving some design related work here. Have you ever talked to Spring people?
Not yet.
Yeah, if possible. Yeah, can you?
I remember you did a presentation.
Yes, I had to make a presentation at the Spring working group, but
that was before the adoption of this one, right?
yeah.
Yeah, so the better you talk to Spring people about the things.
That's a good feedback. Maybe I think we should ask the folks from Spring Working Group to really provide some feedback.
Yeah.
Maybe I think we can formally do that from maybe you are before we do that. I think if you as author, if you can get some feedback, then before the last call, during last call, we'll ask the chair Spring Group to
Yes.
formally provide some feedback.
Yes.
Thank you,
Thank you.
Yair-san. Any other questions? Okay, thanks.
Thank you.
Next, is it map architecture?
Yes.
Okay, map architecture for DMM. Sadara-san is going to give an update.
Thank you. I will present map architecture update and progress after the adoption call. Please, next slide. Okay, thank you. Thank you for your support during the adoption call. Much appreciated. And thank you for the discussion during the adoption call, who made that good, clarified good point. So major discussion during the working group last call is MAPC API related discussion. The one is MAPC API text syntax. The other one is MAPC API candidate. So please go to next slide. So let's summarize the discussion for the map API as the first point. The first point is syntax of the MAPC API text. So in section 6.3, the draft says a map controller called MAPC provides an API. A consumer of the API inputs session information for a UE or AMN from mobile service system. So comment was, so I'm not sure that the MAPC does provide an API as much as consumers consume an existing API from the mobile packet core XED-N4 to provide DTP UE mapping. Another comment was terminology-wise, MAPC and mobile communication system control plane need to share an API. So info consume or leverage is a good term. So this is one discussion point. So next slide, please. So second discussion point was candidate for MAPC API. So the comment was, but I don't think we should specify N4. N4 actually is the interface name of the 3PP system between SMF and UPF. As an implementation may decide to directly integrate to the SBA, service-based architecture, over an SMF, interface of the SMF, or some future API. So his suggestion was MAPC controller, MAPC consume an existing API from the 5G packet core, which provides it with UE and or MN session information. Next slide, please. The second comment on the candidate map API, MAPC API was technically the draft focus on what happened southbound to the MAPC for the API between the MAPC and the mobile communication system control plane. I see another draft apply here, and they can complement the map architecture draft. So the link to the traffic sharing draft provided by Marco. The current revision define a clear scope of which is API between the transport controller, dedicated application built on top, such as MAPC or mobile traffic steering controller. It's all about the traffic steering draft. The same API may apply in between the routing function and the mobile communication system user plane anchor. The current API semantics, which is under development, it means traffic steering draft, can be enriched with session information, where the MAPC derives routing information from. Thank you very much for all of your comment and discussion in the mailer. Please go to next slide. So, consider the comment and discussion on the working group adoption call. So also I would like to reply to that discussion as follows. The first point is the map API text syntax. The purpose of the MapC API is to get or retrieve session information. To achieve above that, both the providing, consuming, or leveraging new or existing API should be available option to MapC. So the author will clarify that in next revision. The second point was MapC API candidate. The map architecture is independent from specific mobile service architecture. So the map architecture should be able to use or allow to any possibly existing or new API. So another draft can describe a specific MapC API, but MapC map architecture open for any kind of the candidate for the MapC API. Okay. That's a summary of the working group adoption call discussion. So the rest of this slide just mention about the map architecture is. So almost slide I show here is we already presented in the past meeting, but let me introduce the what is the map architecture is. So in the map architecture is independent from specific mobile service architecture. The map is consumable by any mobile service architecture. The second point is it's pluggable user plane part of mobile service architecture. Map can be coexist with genuine user plane defined in each mobile service architecture, 4G, 5G, or 6G, or 7G, 8G, NEG. And last point is the map architecture should be independent from a specific data plane protocol. So in the beginning phase of the discussion, we specify the architecture with very much SRv6 specific, but now map can be implemented with any data plane protocols. SRv6 map is a map architecture implementation by using SRv6. The note is that GTPU SRv6 translation behavior set defined in RFC 9433 is one of the options. Okay, next slide, please. So rest of the slide describe the principle of the map architecture. Let me make sure to my presentation. The segment defined in map architecture is defined as the mobile user plane abstraction in map architecture. We have two types of map segment. One is interwork segment facing to the mobile system user plane, and the other is direct segment facing to the internet or data network side. In the map architecture document, the segment can be seen, be defined in the map architecture segment. You can observe the same terminology segment in many technology, and is defined each technology context. But the segment in the map architecture means the segment defined defined as in map architecture. It's not specific for map segment routing. Okay. The second principle was the segment auto discovery. So MapP should be able to discover map segment in the remote MapPEs. The MapP advertise auto discovery route for hosted map segment. The map segment auto discovery route is described in section 5. Interwork segment discovery called ISD route. The other is direct segment discovery, so called DSD route. So the data plane independentness be kept with the the specific protocol, BGP, for example. So any data plane specific attribute should be able to attach to the auto discovery route. Service seat in BGP prefix seat for SRBSC map case. The other data plane option be available when you find the data plane protocol defined in the BGP tunnel encap attribute that allow you to pick the any data plane options. Next slide, please. So this is the order of the option defined in the tunnel encap attribute. You can pick what you like. And please go to next slide. The last principle is the transform session to routing to leverage data plane protocol to optimize the data plane for DMM. So session transformed route, so-called ST route, described in section 6. The ST route advertised from map controller, map C, defined in the following red. Type 1 ST route, type 1 ST route, so-called ST1 route, otherwise type 2 ST route. So auto discovery route should be used to resolve reachability for the ST route. ST route should be data plane independent as well. Okay. So this is the overview of the map architecture depicted in the these two figure. On left-hand side, you can see the map controller on top and map PE deployed on left-hand and right-hand side. Left-hand side PE face to mobile network user plane, N3 LAN, for example, in 5G case. Right-hand side PE face to the N6 side in 5G case. Each PE route exchange a route for mobile map segment route. Right-hand side PE advertise the direct segment discovery route, and left-hand side PE advertise interwork segment discovery route. Okay. The map controller advertise type 1 or 2 session transformed route based on the input from the mobile system for session information. You can see the very abstracted network view on right-hand side. So in the SRv6 network case, each P hosts the above VRF. On left-hand side PE, the PE hosts N3 LAN buff and N6 buff as well. And right-hand side PE hosts N6 DN buff. Other PE may host the UPF connectivity using the buff to connect to the N3 side of the UPF and N6 side of the UPF, respectively. Please go to next slide. So this is a reminder what's the DMM requirement defined. Early stage of DMM co-chair sitting on the here. So thank you very much for joining and resume your work in DMM. Not resume. Okay. So please go ahead, go to next slide. So this is the FAQ. The first question I receive frequently was, isn't RC9433 SRB's map itself? The answer is RC9433 defined SRB's mobile frame behavior under the 3GPP 5G architecture, which is not adopted by 3GPP. The next question was, what does RFC9433 contribute map architecture? The answer is as map architecture designed as pluggable user plane for any mobile service system, RFC9433 provide a data plane option in SRv6 case under the map architecture. Okay. So these three pictures show the some of the characteristics what the operator can achieve with the map architecture. The one is end-to-end network slicing without hassle, and optimal data path for MEC, and optimal data path for D2D, device to device. That's three is the most easy to understand or most easy to see the map architecture enable network characteristic. Next slide, please. So this is the some of the introduction what happened in the network, our commercial network, and the SoftBank already started the field trial using map on with the yeah. So the SRBC map deployed in one of the commercial network in MNO in Japan. That's the brief introduction for the trial happened in SoftBank in Japan. Next slide, please. So this is one of the event which deploy SRBC map for the music event in last year. One of the major jazz music festival, we have a remote ensemble event through the 5G network, but in normal 5G network, it can't host that remote ensemble session because the long latency exists, even the just 300-meter distance between the remote ensemble venue, because the detour user plane route cause the long latency, which is not able to do remote ensemble. But once map is enabled, the user plane path dramatically reduced, and also the latency dramatically reduced as well. Then 5G network be able to host that remote ensemble session successfully. Please go to next slide. This is another trial for long distance drive with the AI dashcam. The dashcam video be sent it to MEC server to inference the object in that video. So that be enabled by maps PE cut through the user plane path to make sure the lower latency and make server access without UPF in front of the server. Okay, so this is another event. And sorry, please go to the next slide. So in terms of the interoperability, we already have a good result between the multiple implementation for MAP, BGP, SAFI. We have Arcas and Cisco, Furukawa, and BB Sakura with some of the open source BGP implementation. We did successful interop event during the IETF hackathon in Yokohama. It was already 2 years ago. So, and please go ahead, go to next slide. So, and also if you are interested in to see the live demo or working code, I can show you that working map demo with my virtual lab. Okay. Okay, so next step, we will clarify MAPC API text, and also we will ask working group score through after the certain level of the review. Thank you very much.
Thank you, Sator-san. Thank you, especially for the updates on the trials and demos. That's great to see that. Any questions, comments? While reading some is coming.
First of all, Deng Hui, I work for Huawei. So first of all, to apologize. I didn't really get the idea, but I try to understand by asking question here. The first one, you're talking about a session. When we talk about a session, what do you mean? I mean, normally UPF have more than 1 million session. Is there? I mean, the session has so many parameters and also buffer needed to cache in order to proceed. So when you're talking about your session here, are you consider same scale of the performance of your proposal? I'm not sure I understand this part. Let me say my second question. You talk about co-hosting N3, N6 interfaces, UPF. So for that co-hosting, I mean, for my understanding, today's implementation, nobody consider like PE or UPF will be co-hosted. In your mind, what do you mean you want co-hosting here? Can you elaborate it a little more? Then I can continue to talk. Thank you.
Okay. Let me answer first question. So the session is the session defined in each of the mobile system. In 5G case, the session is defined in the CGPP spec, which includes a bunch of the information parameter. But to create the routing information for the map, we can retrieve the parameter necessary to generate the route. For example, UE route, UE address, UPF address, TID, or QFI or something to forward the packet. So rest of the parameter or metadata kind of the things not be transformed to the route.
Okay.
It depends on the mobile system. Session definition be different, but map architecture allow us to adjust each of the mobile architecture to get appropriate information from this session information.
Let me continue. So I think for the session parameters of today's mobile communication, today based on 3GPP specification, based on operators' requirements, those parameters is very long. I mean, not just IP address, not just
right.
tunnel ID. They cannot be coupled. Are you talking you want to separate them to different processing procedure? Are you consider that idea?
That could be related to the MAPC API discussion. So
okay.
The map architecture doesn't specify the specific way to get that session information, but some of the implementation or specific idea to get the session information, that could be a solution to implement map architecture as a pluggable user plane for that specific mobile system.
Okay, so I think API will be performance bottleneck if you rely on the other way, because today's processing is more like they are pursuing the efficiency to deliver the packet. After processing of the attributes as quickly as possible, then forward it, right? So that is a mandatory requirement for each vendors. But if you don't do that more efficiently, then not competitive for the marketing, in my mind.
Do you mean the packet forwarding at the user plane?
Yes.
No? Okay. So I think the same thing happened on both of the UPF and the MAP PE, just decap, encap, for the GTP header or encap SRv6 or decap. But the remains the data user plane behavior
Yes.
to be a how to say accounting or
quality of
QoS could be the possible option for that, but here the DMM and focus on the mobility system, so the accounting, billing, or
Out
some
of scope,
other
okay.
lawful latency, lawful intercept could be out of scope.
Okay.
It
But
could
anyway,
be-
I raised this because
Yeah.
you are proposing it. I have to think about the reality. Okay, let me go to the second one. So what do you think? Are you, if you consider co-hosting, if you only do tunnel processing, address source address, destination address processing, that should be okay. But today is not. I mean, mobile communication doesn't really do such a simple work. But if you only do such a very simple requirement for co-hosting, then that's possible. That's my
Yeah, of course.
understanding. Okay.
This is the reason why map architecture for DMM.
Okay.
So, okay.
Okay. Thank you. Very interesting.
Thank you.
Charles has a question. Charles?
Yeah, thanks, Charles Eckel. It's Hui's question kind of made me think about this. Is the idea that my assumption was of the session information, there'd only be some subset of that really influences the routing decisions that
Right.
would need to be made. And so while there's a whole lot of session information, it's a I think relatively small subset of that you would need right access to. You wouldn't necessarily
Right.
need all of it, and it's just that small subset that you would need to capture for it to work within the MUP architecture.
Yeah. Routing information just require just IP address or next hop, just that. But rest of the parameters should be some of the hint or could influence the routing decision. So
Okay, that's reasonable. I think if we only talk about the routing, processing only part of the parameters, maybe reasonable, feasible. But as I talked in the beginning, when operators are proceeding those kind of parameters, they have to proceed this all the same time to achieve the performance. But you cannot just
what do you mean by performance? Is that a control
Performance
plane
mean-
performance or user plane performance?
user plane performance. So we cannot do like a two-stage. I mean, two phases. First is just routing the traffic. Then secondly, you're going to handle like the quality of service other part. I think quality of service is also another routing related parameters. So it's not a. So I need to think more about whether we can do like two phases routing.
Okay.
But at least I think it is need more research or consideration. But okay.
Your consideration really highly welcome. And one thing I want to let you know that the QFI could be carried in the BGP message.
So Hui, with that, would you be able to review the document and provide some comments? That's a great opportunity for you to, yeah? You're sincere, yeah?
Yeah, I need more time. I'm too
Okay,
busy.
sure, that's fine,
But
that's
if you,
fine.
I think when he goes on his working group, let's call now. Okay.
Great, thank you.
Yeah,
I will think about this because take that to be.
Okay, thank you. We are on the note taker has taken that. So please, yeah.
Yeah, thank you, Lionel. On the first one, on the MUP-C API, if I understood correctly, it's not so important to say API even here. The only thing that you would like to say is that the controller has interface with the mobile system and is able to receive some required information. I think you can just reward this paragraph to say that, because it is not intended even to, because when you say the MUP-C provide this API, it is intended, or it is assumed that these APIs will need to be defined, and actually it's out of scope of this document. You just say that there is whatever the implementation of this interface. Is correct?
Correct, yes.
Thank you, Lionel. Any other questions, comments? I think one question, Satoru-san, is the MUP working code open source or is it your private? The working code.
Working code, we have a open source code here,
Okay.
and BPP on data plan, and the Go BGP and other BGP implementation, like the BIRD. That could be the open source option.
Okay, great. Thank you.
Some question regarding your the location. You're going to put your PE and via the Genobi and the UPF, the N3, N6, all kind of things. You have a very good picture there. But it really confused me. There's one, I think you have architecture, right? Showing the general architecture and with the 5G. Now this one going back. That one really confused me about what you try to achieve. There are two pictures. Oh yeah, this is the one. I think Hui mentioned something, a very good point is for the UPF, actually, when the UPF does receive one incoming datagram, a PTU datagram, normally it's not going to run routing. It's going to use the PDR, the packet detection rule, those type of things to detect it, and then to use the QS enforcement rule, and then use FAR to do the work. But this one is confused me is where are going to you're going to put your PE, left PE and auto right PE, the N3 PE and N6 PE, all kind of things. This one really confused me. Can you explain it?
I think it would be better good picture to imagine how map architecture works. So yes, you talking about the 5G architecture, detecting the packet based on the PDR, PDI, but in terms of the map architecture, those session information be transformed to the routing information. In routing sense, find the destination and then decide the next stop, just that. That the packet detection rule be transformed to the routing information. That's what MAPC doing. And then just doing the routing at the PE is the map exactly doing.
Okay, I will read your document here. It really confused me, but I understand. Yeah, thank you. Anyway.
Okay, John.
A similar question, but more specifically about, for example, if you have paging, a downlink data notification. So for example, you have a packet that comes to the UPF.
Okay.
And then what happens? How do you know where to route it? Because it could be a different route that's set up based on that DDM.
Okay. So let me explain very briefly. So we have to note that UPF still connected to the network, not get rid out of them. But so once the forwarding state be idle or buffered, that session information not be reflected, distributed, advertised to the map PE. In that situation, how router forwards that packet towards the idle session is based on the longest match. So let's imagine UPF on N6 UPF buff advertise the shorter prefix of the UE address block. And during the session activated, the much longer prefix, maybe host route be advertised from map C and install the fib on the PE. So during that, the map P can forward the packet to the UE directly. But once the session information be idle, then map C stops advertisement for that UE route. And then the left-hand map PE forwards the packet to the N6 buff, N6 UPF buff, and then reach to the N6 interface of the UPF.
So
the longest match, it's routing.
Yes, but it's also maintaining timers to time out that route.
Time out what?
Time out when the UE goes to idle. So some kind of a timer after the DRX and the power save mode. So that at that point, the route should not exist. Is that right?
Yes. During the route is not existed, the packet forward based on the longest match follow the shorter prefix route.
Okay.
we'll take the last question.
Yeah, just the follow up. Try to sort out what you had just explained. To me, it's like you have the control plane of the mobile wireless to set up all the sessions, and then you use your map C to sync with the control plane of the wireless to get all the information downloaded to your PE, and then only after that can you bypass the mobile the network by only using the things.
Yes.
Okay. Okay. Sure. Thank you.
Marco?
Very quick question. So I think I reviewed an earlier draft of this and provided my input and review comments here. So just for curiosity, coming back again to this terminology thing, which is the MOB controller, which exposes or leverages or whatever makes use of this API to retrieve the session information. So of course, it reads session information. I don't recall if there was anything that's pushed back from the MOB controller to the mobile communication system. Is that direction also included, or is it just reading and then converting to routing information?
It depends on the solution, how to get the session information from mobile system. So, for example, the map controller could be a control plane of the UPF, or maybe map controller be implemented with the SMF. In that case, the map controller can retrieve the information and send back the status to the mobile communication system. Path be established or not. That could be an option, but totally depends on the specific implementation or solution.
I see. Thank you.
Any other final questions, thoughts? Okay. Thank you, Satoru-san.
Thank you.
Okay. Our last presentation, I believe, Marco, right? Oops. Sorry.
Is this to proceed, or you need to?
Oh, I don't think it's working, right?
No.
That clicker is not
Okay.
working. Yeah, I can.
All right,
try this.
mobile traffic steering. So we discussed that a couple of times during the past IETFs in between. So we recently published version 3. And just to quickly motivate this work, if you can go to the next slide, please. So mobile communication systems are not end-to-end. So that means depending on the deployment of that system, some use cases, and in particular advanced use cases that are being discussed, require more control on the end-to-end traffic in the view of service continuity. So what that draft discusses and proposes is to extend and complement the control of a mobile communication system for end-to-end traffic steering towards the data network and across the transport network. So DMM working group exists for a very long time, and related use cases and drafts have been discussed in the past. And so we revisited them and referred to them, but started concretely talking about extending mobile communication system for traffic steering at IETF 116, and had a public site meeting at IETF 117 with very good feedback and discussion. So we thought about, is there room for documentation and maybe even standardization? And that has been further elaborated and also summarized in the draft. So the third revision, we believe, is very clear on its scope. So as always, we start with a framework, but we don't standardize a framework. We cannot do that, but see what's there, what other groups are doing. And we broke down the gap that we want to close to clear interface between the mobile communication system and the routing infrastructure. And so we defined the scope, the interworking options. We came up with a couple of use cases and deployment options, and complete the draft currently with an information model. Next slide, please. All right, so regarding the reference intent architecture, we assume a mobile communication system, which you see on the top picture on the very left side. So here we don't take any assumptions and also don't want to enforce any dependency, but assume the typical architecture, which has a communication system control plane. We have a user plane. Here you see a radio network with mobile users being connected. Then on the very right, you have a data network where services are being provided by instances of an application service functions. They may be controlled by an application control function. And in between, there's a transport network with data plane nodes. Picture below, we just added recently because there was the question of the previous figures, this one-to-one dependency between a data plane node and a user plane anchor. That doesn't exist. So in particular, we want to support any flexible constellations between groups of user plane anchors, data plane nodes, and data networks. Same on the data network side. Next, please. All right, some exemplary use cases. There are far more, but we wanted to take some of them and describe them to make clear why this may be needed. And so one is user plane anchor relocation mid-session. So in the view of service continuity, mobile devices may be mobile, and the mobile communication system may decide to assign a new user plane anchor, or it may decide, take this decision because of load balancing, or there is a failure which requires a failover scenario. So these are obvious scenarios. Also, we can think about multiple user plane anchors that serve a mobile device at the same time, and we steer traffic according to policies. These policies may include also security aspects, for example. Node ephemerality. So that may apply to all these relevant components: user plane anchors, data plane nodes, and data network. So all of them may change for various reasons. Either they are mobile on their own. We think about mobile user plane anchors, mobile data networks, maybe due to the user mobility, a data network is being changed and the traffic in between needs to be updated in terms of how it's being steered between these two endpoints. Also, energy may be a reason why some nodes may not always be available. So there are various use cases. We list them and describe them under the umbrella of node ephemerality. Route optimization, it's a very obvious case when you have multiple or two users talking to each other, and they are both mobile, so their user plane anchor being assigned to them may change, and then traffic needs to be steered accordingly. End-to-end QoS, it's something that came up from the very beginning. So far, in particular, the information model does not take them into account yet, but we just wanted to give a starting point and may have that extended. Also, if this is something that can be leveraged by a mob controller, for example, session information is something that we can add here. Next slide, please. All right, so we mainly focus on two deployment options and later describe how they can be used in three operational models. So one deployment option is that we assume a dedicated control plane or controller on the transport network side. So we apply the interface that this draft specifies, which we call control interface of mobile traffic steering. And as you see here, if we have these two controllers, we want to align the traffic steering rules, decisions, changes in the mobile communication system with the rest of the network and the transport network in particular. So we define and apply this, we call it API, that may be any semantics over a protocol between the mobile communication system control plane and the mobile traffic steering controller, as you can see here. On the data and user plane, we assume there is a forwarding plane. On both nodes, the UPA and the data plane node, rules and policies are enforced by the associated controller. Below, you see a decentralized control plane. So that's the other extreme case where the transport network relies on a distributed or decentralized approach like BGP or any routing protocol and doesn't have dedicated controllers. There are limits to that, but it's a working procedure. Shall we complete or even in the meeting? Yeah, if it fits to that one, just go ahead.
No, it's fine to take it at the end.
All right. Then next slide, please. All right. So if we take this, these two deployment options, so we have a description of operation. So that was a request that we add operations, so how the whole thing works. So we added some scenarios and some for each of these modes. So mode 1 is controller-centric operation based on an MTS controller, which may be built on top of a transport network controller, but leverages this API towards the mobile communication system control plane. And as you can see with this red, yeah, it's red, dotted line, so each control plane enforces the routing policies and rules down to the user and data plane through their own interfaces. If you move to the next slide, we have the other extreme case, which is operation mode 2, which is decentralized. And so the transport network and the data plane nodes, they receive information through the user plane anchor, which exposes then these changes or updates through this proposed API to the data plane nodes, which then further propagate the updated routing rules towards the transport network. And operational mode 3 in the next slide, we call it hybrid mode. So we may have a dedicated controller in the transport network. We did not include any kind of interface towards the data network. It may exist, but that's not what we focus on, right? So we may have such an MTS controller, even though it does not push updates of routing rules to the transport network, but has this interaction with the mobile control plane through the proposed MTS API. And then we leverage the mobile communication system control plane, updating the user plane anchors, and then leveraging again this API as in operation mode 2 to push updates towards the routing plane through any kind of routing protocol. So that's what we call hybrid mode. Next slide, please. So that's the current structure of the draft, where we started with a reference architecture. We added these use cases that we addressed before. If there is demand for new ones, which make a lot of sense, we can add them. More important, the framework and deployment options are described and separated from the operational aspects. For the operational aspects, we focus on topology considerations, and then in particular on the 3 modes that we just described. And in the back, we currently have a model of, well, the information models. Still here, if you move to the next and last slide, we want to unify the formats of the information model, where we propose a structure to do that, and also extend the elements that we think are useful to control this end-to-end path, and also extend the operations section with more examples to make how to use this API clearer. And well, we asked that question a couple of times if there is interest in the working group, and obviously there is, which we received through various questions after the presentation, but also in between and offline. So if it makes sense, and we have version 3, which we believe is pretty mature, it's not complete, of course not, but I think the structure and the scope is well defined. So if the working group thinks there is value in it, let's call for adoption or not. That's
Thank you, Marco. I think any questions, comments? I think John reading, right? I think one thing before John, you say, so I think we asked for explicit reviews, and a bunch of people last time signed up. I don't believe we saw any discussions in the mailing list, but we'll go back to that. Yeah, John.
Thank you. I think this is definitely a gap in 3GPP or end-to-end specification, not 3GPP specification, but for the end-to-end flow that this draft addresses. So I think this is a valuable contribution for sure, but I do have a number of maybe clarifying questions or things like that. So I think I wrote it down. So one, yeah, if you look at this figure, between the controllers, is it per flow or is it an abstraction that's taking a group of flows um, in terms of scalability and things like that? So that's one question I have.
An association between the controllers is not per flow, but so the semantics for traffic steering and the resulting traffic steering policies, well, most sense makes it on a per user basis or per session basis, right? If you break it down to policies that apply on a flow level, maybe good or bad, right? But the semantics are flexible here. It depends on the deployment. If
I
it's
was
needed,
thinking
then
more the opposite way, which is can a group, I mean, a whole prefix group of,
yeah,
you know, because with thousands or hundreds of thousands of flows or, you know, users,
yes.
you know, some kind of abstraction would be useful. So that was the thought there. But also, when I was reading the draft towards the end, I see a DPN PE. It's not in the figures, but then for the MCS side of the network, there was no PE per se. So my question more or less is, what are the providers in this case? There's a provider edge, there's a DPN provider edge, but is there an MCP provider edge?
Also here it depends a lot on how it's being deployed and which or how many autonomous systems you have involved in that, right? That was one of the comments that we received from Joe Halpern during the public meeting, site meeting. So here we have a simple assumption that a DPN is, or one DPN for a mobile is associated with one UPA. So the DPN may be something close or collocated with a UPA, but it may also be a PE, right? The same we have on the data network side, that this shown DPN may be something, the last, let's say, router in the transport network, or it's maybe the PE router of the data network. So it really depends on where you want to enforce these traffic steering.
Maybe we can take it offline, but I was thinking that even if it's the same operator, usually they're different providers of some sort. You know? But okay, we can take that offline. I did have some other questions also. Maybe we talked briefly about this. So it looks like this is handling routing a lot. I mean, and steering and all of that. But can it handle other QoS policies like, you know, aspects of slicing and isolation? And I think I know the answer, but I just wanted to.
Of course, we started with the very basics, which is bringing traffic and data packets from A to B, and A to B is end-to-end. If these packets should be forwarded according to particular traffic engineering strategy or policy, that's something that can be added. And we added this also in the use cases, right? And in the draft, we mentioned that too. But the information model currently does not focus on QoS specific elements, but it makes a lot of sense end to end. So if the mobile communication system typically applies some prioritization of traffic, that you do the same on the remaining path, which is between the user plane anchor and the data network. So if that QoS changes, then a QoS semantics being added to that API makes a lot of sense, yes.
Thank you. I must say that I like the proposals.
Thank you, John. And last but not least, QoS may imply or include slicing. I see in slicing more kind of isolation rather than prioritization of packets, but it's extensible.
So Mark, on the related, John's follow-up on John's question, right? Does TN controller have the semantics to enforce cost QoS policies, or is it mostly route policies?
Which one?
On the TN controller, if you're using TN controller for.
Well, that depends on how you develop and deploy the transport network controller, right? So we just moved from having a plain transport network controller talking to the mobility control plane. So if we have a TN controller, it has a kind of northbound API that can be used by applications where we wrap around this MTS control as one application. If QoS is to be enforced and the control data plane protocol in the transport network supports QoS, of course, that can be done.
Okay. Yeah, Denghui. Yeah.
Okay, Deng Hui, and I think first of all, I mean, you are using different terminology here. First one, you're using MCS, and then this page you show the MCP. Is that a difference?
MTS for mobile.
MCS, I think the previous figure, last page, I think you are using different terminology. Are you always using MCP? Or MCS control plane?
Yeah, so
Okay.
we abstract the mobile communication system and just focus on MCS, mobile communication system control plane, and the user plane anchor. And on the transport network side, we have the MTS controller, which is solely for the transport network, and data plane nodes.
Okay.
So just also from the terminology and functionality point of view, it's a separation.
All right. So I have two comments. First one is my instant memory regarding the mapping between the N6 interface. I mean between the UPF to the DPM part. Today is no not coupled. I mean it's more like doing separately. So here the purpose is trying to do some mapping between them and have the unified control on this end-to-end.
Yes.
Okay, I understand. Okay, so why we need this?
Why we need this?
Let me clarify why I ask this. The reason, the mobile side. I still have question to the map architectures. I mean the session is more like I think John talking about the synchronization with the group, but I'm not convinced that because the reason is the session on the mobility part is more dynamic. I mean we have like 1 million users. They have different policy. What do we mean control plane here? I mean, if we look at the mobility control plane, they have the service bus, SPI bus, right? So when you're talking about the control plane, are you talking about the session management, SMMF, or are you talking about the which functionality? I mean, because the control plane is too wide, I mean, for the mobility to consider. There's no place in the mobility who is talking about here the central control plane because they are diversified. I mean, they are service-based architecture, right? So the status is deposited in different functionality. When we talk about control plane, if you do group synchronization, that doesn't exist because they have multiple type of the status in different functionality. And so I think that's another, but to be honest, I think that you're talking about the mapping. I totally support this draft to be adopted by the working group. I'm just thinking about, does this make sense for the mobility communication? Because
your audio dropped.
Battery time over. No, but I get your point. And first of all, thanks for your support. We need to clarify these questions. They're important, but I also understand you're talking 3GPP, right? So here we, of course, the mobility control plane has different instances with different roles like SMF, AMF, NEF. So we look at a mobile communication system that has its role, which features its support today or in the future. We try to abstract from that, right? But we see just a clear separation in what we have today, and that may still be there in the future, like a user plane anchor, right? And your question about why you need this. So a very simple example, if this needed or not. So if you have a anchor relocation and you need something like at least temporary IP address continuity, yeah, you may not need this, but if it's needed, so you deviate from the default routes in the transport network. That means you need to apply host routes, for example, to bring these packets to the new user plane anchor. That's a very simplistic example. Of course.
Yeah, you can join him. Yeah.
all right, so as I use my time very efficiently, hopefully. So I think we talk about the anchor movement, not only for 5G, but starting from 3G, we are talking about anchor always moving. The car is driving, the anchor point is always moving. So we are assuming these use cases. But to be honestly, from 3G, 4G, 5G, we have tackling this problem for a long time. But still, it's really hard in the real use cases to find this issue. But anyway, this we could continue, right? Sometime it come. The secondly, I continue to for your architectural designing is the control plane is too many starters. It's really hard to synchronize with outside. MF, PCF, SMF, all of them has a different session starters. They have the different state machine for the session.
That's a 3GPP issue.
Okay, that's good question. Thank you.
Yeah,
Thanks for the short
thank you,
answer.
Dangwei. Okay, any other
you.
questions, comments? Okay, folks, we want some reviews of this document. Who last time bunch of folks signed up, but nothing came up. So who is any volunteers? At least folks who have commented should, yeah, John. Anyone else? Okay, Carlos. Okay, thank you. Any others? Okay. Okay.
Thank you.
Thank
And
you
if
so
you have more
much.
comments or questions,
Yeah.
we're here the whole
Yeah,
week.
maybe
so-
one follow-up question on mode 2
Sure.
and mode 3. Is between the UPA and DPN API interface, is that practical between two user plane nodes, an API type of interface?
We had that discussion too. So if you have a separation between the data plane node and UPA, so if we talk about the popular segment routing and the UPA, well, we don't assume the UPA has the implementation of these kind of protocols, right? So we have a separation. Even if DPN and UPA run collocated, they need some interface to talk with each other, right? With Jeffrey, we discussed in particular if that API can be used, if a routing protocol like RIP can be used here, but still the semantics that we define need to be added, right? If that semantics is added to a routing protocol or to a REST call or message bus kind of communication, we are not specific to that, but we see the need to exchange, if we don't have a dedicated control plane in the transport network, to exchange that semantics and control, operational control between a UPA and a DPN, leveraging that API. How it's being implemented is a different decision.
But I would think if you support such a model, we need to at least decode and say how a system can realize such API, right?
Yes, of course.
Yeah,
Yeah.
I
But
think
that
because
requires, we
yeah.
don't want to jump ahead, right? We
Yeah.
first want to define the scope and a starting point of information model, but recommendations or best current practice, how to implement such an API we can add, but we want to have the discussion with the community on that.
John.
Yes.
Maybe it's a related comment, but I wanted to say that in 3GPP, the UPF is more a server, not necessarily a router.
I would strongly disagree with that view, but
Really? Okay.
yeah,
Because you could just default route to another router.
No, but these are routers, right? They can transfer massive amount of data, right?
Yes.
Those are not servers. So
No, what I mean is that it's built on top of a router, an application on a router. So I guess when it comes to interfaces, where is that interface? It is on the router or on the application, the UPF. That is the question.
Definitely the information is to be retrieved from the application's conceptual data structures. Right? It's not routing information only that we retrieve from the UPA.
But if that is the case, then it's a 3GPP related thing also. So that was a question.
Okay.
thank you, John. Any final thoughts? If not, we wrap up this meeting. So that's all. Any business?
Thank you.
Thank you so much for all the participation. Thank you for the comments, feedback, discussions. See you guys in the next IETF. Montreal, IETF 124, Montreal.
Yep.
Thank you so much. By then we'll learn some French. Okay. Thank you. Carlos? Oh, Eric? Yeah, sorry.
I was just going to say, Mahesh, UpsAD said that
Yeah, I just heard back from one of the ops ADs that Yang modules do not have to be PS.
Oh, it doesn't have.
Yeah, we should be able to stay informational.
Oh,
Okay.
Oh, thanks for
Yeah.
the clarification. Okay.
So there are all Yang modules to date have been PS. There are some in the queue right now that are experimental, and so they're basically saying
Okay.
we should be able to stay informational for now.
John, this is also issue. Okay, very good. Thank you so much. I appreciate it. Very much appreciate it. Thank you. Thank you. With this, we wrap up the meeting. Thank you. Good chair.
Good chair. Through
Yes.
DMM chair.
Without asking help on this tool. For the first time. On the open source, I wish you can publish some on the open source. Hi, Derek. How are you doing? Good to see you. Yeah, how are things? Yeah, yeah. You noticed.
No,
You know-
I don't notice that until I come
Oh
over.
wow, that's
Sorry,
good.
sorry.
Oh. I'm offended. He never looks at me.
My hobby is the sharpen the shape. So I really wanted to do the shape of your.